A spanner is dropped from a 6th floor window and takes 2.2 seconds to hit the ground. Alright, height from which it's dropped and its impact velocity. So, what do I know and what do I want to know? It's worth stating each time. I'm going to use the convention that up is positive. Okay, that's my shorthand to say up is positive. If you prefer, you can draw it the other way and say down is positive. I'm going to stick to this convention. It's dropped, so its initial speed is 0. Takes 2.2 seconds to hit the ground. What else do I know? I know acceleration is negative 9.8 meters per second squared because it's gravity. The height from which it was dropped, that's A, except it's actually going to be negative, and its impact velocity, that's B. Alright, which rule involves, for A, U, A, S and T? Well, that's our old friend, well, I do it down here, A. S equals ut plus a half at squared. Now, I said earlier S is going to be negative. The reason is it's falling downwards, but up is positive. So I'm expecting a negative answer. Its initial speed was 0. I don't need to worry about the time. Negative half of 9.8 is 4.9. Oh, sorry, times t squared, but I know t, times 2.2 squared. I'm not going to try and do that in my head. 4.9 times 2.2 squared, 23.7. Negative 23.7 metres. So, it was dropped. Always best to answer in words for a word question. From 23.7 metres. Notice S was negative, but I know that we're talking about a height. For B, its impact velocity. Now I now know S, but I could have made a calculation error. So to calculate V, it's better to ignore S. It's better to use the numbers in the question rather than one I've worked out. So what involves U, V, A and T? That's V equals U plus AT. So U was 0, acceleration is minus 9.8, 2.2. I could probably do that in my head, but why bother? 9.8, 21.56. Negative 21.56 meters per second. Impact velocity. Now when you give this again, this one was a height, dropped from. This one's negative sign means it's going downwards. Impact velocity is 21.56 meters per second downwards. Here's two more examples. A person aboard a balloon moving downward at 20 meters per second drops a sandbag at an elevation of 500 meters. So, let's write down what we know. Okay, they're moving downward at 20 meters per second and then they drop the sandbag, which means when they let it go, the sandbag is already moving at 20 meters per second downwards. Now I'm going to stick to my convention that up is positive. Doesn't matter, pick one, be consistent. Alright. The speed of the bag on impact is part B. Acceleration is minus 9.8 meters per second per second. Oops, meters per second. The displacement is going to be 500 meters downwards. Okay. So from where I let it go to where it hits is 500 meters. No, that's not right. From where I let it go to where it drops to where it hits is negative 500. It's downwards. and t, the time, is part A. So let's try and solve that. A. What involves u, a, s and t? S equals ut plus a half at squared minus 500 is minus 20 times t, which I don't know. Let me just leave it as t then, minus 20t. Half a is negative 4.9 t squared. That's a quadratic. You can try and solve it in your head, or you can do this. I'm actually going to rearrange to the other side. 4.9 t squared plus 20t minus 500. And I'm going to use my graphics calculator because I can. Equation, polynomial degree 2. 4.9, 20, negative 500. Solve. There are two solutions, but my solution must be the positive one. So, t equals, better say, using graphics calculator, t is 8.2648 seconds, or minus 12.34, but must, in this context, be positive. Therefore, we'll take two significant figures should be enough. 8.3 seconds to hit the ground. B. Ignoring the thing I just worked out, which was t, can I solve for v using u, a and s? Yes, I can. V squared equals u squared plus 2as. V is what I'm looking for. 400 plus 19.6 negative times negative 500. So 400, 400, they're going to become positive, plus 19.6 times 500, 10200. Now, careful here, v squared is positive, but I know that it's going to be moving downwards, so v is actually going to be the negative square root. It has to be negative because it's going to be moving downwards. Same kind of logic as here, we knew what it had to be. Square root of that number is, that doesn't help me, give me a decimal please, 101, let's round off sensibly, 101 meters per second. Impact speed will be 101 meters per second downwards. Let's try the next example. A ball is thrown vertically upward at 20 meters per second. Ignoring air resistance, work out how high it goes and how long it's in the air. Okay, I'm going to do these separately. So, U, V, A, S, T. Now for this we have to think cleverly. So, vertically upwards, we're still sticking to up being positive. Vertically upward, maybe I'll write that as well. Up is positive. 20 meters per second. Acceleration's minus 9.8. And I have to work out how high it goes. I seem to have a problem. I need 3 knowns to work out a fourth. Actually, there is something else I know. I know that when it gets to the top of its swing, it goes up and then comes down. When it gets to the top, its speed is 0. Instantaneously, just very, very briefly, its speed is 0 at the top. So I'm going to put 0 in for V, and I'll be able to work this out. I need to link U, V, A and S. It's the same as this one. Am I going to fit it here? Let's try. V squared is U squared plus 2AS. There's a V. 0 is 400 minus 19.6S. So 19.6S is 400, and then divide. Haven't got quite enough room to write it. I'll go sideways instead. 400 over 19.6, which is 20.41. And it's positive, that's right, 20.41 metres. How come this one's positive and the other's negative? Because this one's thrown upwards. I'm throwing it up. If I throw it up, its displacement will be positive at the top. Now, to work out B, again, think cleverly. It's going to go up, and then it's going to come down again. The trip down is the exact mirror of the trip up. So the time taken for the whole trip will actually be double what it is for the first half. If I knew the first half, I'd be able to get there quicker. But I don't, so I'll have to go the long way anyway. U, V, A, S, T. Now, initial speed is 20 metres per second up. Acceleration is 9.8 metres per second squared. Whoops. Now, when it gets to the bottom again, I know two things, and I can use either. I know, because it's a mirror, that the vertical speed downwards will be negative 20 metres per second. Or the vertical displacement will be 0. Both methods work. Pick one. Because I just did one with V, I'm going to do this one using displacement to solve for the time. I'm looking for time. I'm going to use this way. So let's give displacement being 0. So when does it come back on the ground again? Well, U, A, S and T. S equals UT plus a half AT squared. 0 equals 20T plus negative 4.9 T squared. Factorise this right away. T, 20 minus 4.9 T. And that's 0 if T is 0 or 20 equals 4.9 T. Now I knew this already. I knew it was displacement 0 at the start. It doesn't help me. This is going to get me my solution. T is going to be 20 divided by 4.9, which is 4.08. 4.1 will do. 4.1 seconds.